Yes, yes. We and see, guys, one more assignment will get added for you guys on the portal, and that assignment's name will be mock, mock test kind ka. So that will also serve as a practice for your mock test, right? Okay. And acha, first of all, please come and change your names, right? So if somebody is messaging with as hacker, you are 100% sure that I won't be responding back. Okay. So please come in with your original names if you expect to get a response back at least. Okay. And for folks who have joined in late, I will just tell you what is the agenda of today's class, right? So first of all, we will be spending the first 1 hour, 20 minutes approximately on Quicksort. Okay. And from 9:20 till 9:50 or 9:55, right? For the 35 minutes, I will be discussing about the mock test. Sorry, not mock test, right? I'll be discussing about the module test. And then I will be discussing about the interviews and what all things you need to keep in mind and all these things. Okay. And yes, I will share some problems with you from LeetCode also. Okay. Cool. Yes, everything will be covered, Kumar, Gitanjali, like what happens if you don't pass in the mocks and everything. Okay. Yeah, okay. So I think we can get started. Extremely sorry, I couldn't check my Discord from the last couple of days, but I think, yeah, actually, I'll try and check it. Okay. Okay. So let's get started, right? Let's get started. Okay. All questions regarding to module test, interviews, I'll take later. Okay. And yeah, I have, disabled the chats. Okay, let's enable it. Somebody was asking for the Zoom link. डाल दो भाई किसी को अगर डालना हो तो. And then we'll just get started. Okay, so you got the link. Now chats are disabled. Great. Okay. So yeah, let's focus for the first 1 hour 20-25 minutes, right? And I'm not a मतलब ऐसा नहीं है कि तुम लोग को रोकने के लिए वो बाद में किया है, but because I wanted to cover Quicksort first, right? Because it has been started yesterday. So first we will cover this, and then I will, answer all your questions regarding to the assignments or whatever, right? Whatever questions you have. I also have some pointers to share with you. So first I will do the talking, and then I will take the questions from you all. Okay. So yesterday, guys, we started. So we will be try to go a little bit fast, okay, so that we can cover it on time and take all your questions as well. Okay. So yesterday we started off with the concept of Quicksort. Okay. And what did I tell you? I just gave you an example of a school assembly. Ki boss, in a school assembly, everyone has to stand in ascending order so that everyone can get a clear picture of the stage. Okay. So let's say, you have to stand in ascending order, right? But now let's say what happens is the line is basically in a jumbled order. I don't know, right? And the teacher comes and tells you, hey, can you please go and stand at your correct location? You are a very good student. And so the teacher comes and tells you, hey, Adarsh, can you please go and stand at your correct location so that I don't have to move you from your place? So what you will do? You will go and stand at such a place such that all the people who are of a lesser height than you, they are in front of you, and all the people who are of a greater height than you, they are behind you. And when you stand in this location, you can very firmly say to the teacher that, hey teacher, you know what, I am standing at my correct location. आपको मेरे को यहाँ से disturb नहीं करना होगा. This is my correct location. Yes, you might have to do some internal rearrangements among the people who are standing in front of me and among the people who are standing behind me. But for sure, you won't have to displace me from my position. So now I tell, when such a formation has been formed, I say that I am standing at my correct position. And I have partitioned the line into, okay, see, this is one partition and this is the right partition. Okay. So the same concept, Quicksort employs, right? What does Quicksort say? Okay, let's say you have an array of integers. Okay, you have an array of integers. Let's take it. Okay. So let's say you have an array of integers. Okay. And I give you indexes. This is index L. This is index R. And I tell you, boss, can you please sort this entire array for me? So you call the Quicksort function and pass it ARR, L, R. Can you please sort the array from index L till index R for me? Okay. So the expectation from this Quicksort function is from index L till R, the entire array should get sorted. Now, what does the teacher tell? Ki boss, sorting this entire line is a very difficult task. So the teacher comes to me ऐसा सोचो, the teacher comes to this number and tells, hey 8, can you please go and stand at your correct location so that my work is reduced a little bit, right? So I choose an element, okay, and the element that I choose is known as the element that we choose is known as the pivot element. Okay. Now, which element do you choose as the pivot? Currently, we are choosing ARR of L as the pivot. Okay. So the teacher is very lazy and she is always choosing the boy that is standing at the front of the line. So we are choosing ARR of L as my pivot element. And what do I say? Hey 8, can you please go and adjust yourself at your correct location? Okay. So what happens? 8 will move forward, backward. Kuch hoga, right? I don't care about that logic at this point of time. But what will happen is, after 8 is standing at its correct position, you can expect that, boss, all the elements lesser than 8, let's say 7 and 5, they will be in front of 8. And all the elements that are greater than 8, let's say 12, 10, and 11, they will be after 8. Okay. Their internal ordering might not be the correct ordering, but I say that yes, now 8 is standing at the correct location. So once the pivot element reaches its correct position, I say that we have created a partition. And therefore, this entire logic, now we say that this is the partitioning logic. Okay. We applied the partitioning logic and the pivot element went and now has settled at its correct index. Okay. So what is this index? Let's say this index is, let us call this index as pivot index. Okay. Pivot index or partition index, whatever you can call it, right? So I actually wanted to sort an array from index number 0, 1, 2, 3, 4, 5, till index number 5, right? So I had made a quick sort call on ARR from index number 0 till index number 5. So first of all, I called the partition function, and what happened? Element 8 went and got, it basically settled at its correct location. And it gave me this index. Ki boss, index number 2 is the correct location for 8. Now the job of the teacher has been reduced. Teacher ko pata hai, boss 8 is at its correct location. So now what will the teacher do? The job of the teacher now is to sort this left part. Okay. Now imagine, guys, try to visualize. The moment this left part gets sorted and the moment the right part gets sorted, won't your entire array become sorted? Yes, see, 5, 7, 8, 10, 11, 12. So if you are able to sort your left and the right parts now, your entire array will become sorted. So what will the teacher do? The teacher, what is this expectation from the quicksort function? That it will sort the entire array from index 0 to 5. So now what I will do, I will say, hey, I will call the quicksort function, right? Expecting it to sort the array. And what indexes do I pass? I pass, hey, quicksort, can you please sort the left part from index number L till index number pivot index -1 or partition index -1. So I will say, hey, can you sort the left part of the array from index 0 till index 1? Okay. Now, first of all, the teacher will wait for this this part to get sorted. So this quicksort function starts running and I have to sort the array from index number 0 till index number 1. Now this is again a difficult task, right? This is again a difficult task. So what do? I again call my partition function. Okay. So this is L and this is R. Okay. When this function runs, L is 0 and R is 1. So I again call my partition function. And what will my partitioning logic do? It will choose ARR of L as the pivot element and make sure that this element goes at its correct location. So guys, the area of interest for me is, if you look very carefully, it is this part, right? The area of interest. And I have chosen this as the pivot element, right? So tell me, in this area of interest, what is the correct location for 7? Index number 1. So what my partition function will do is, boss, the pivot element will go at its correct location. Okay. The pivot element went at its correct location. Just try to follow. This went at its correct location. It will give to me back the index. Ki boss, the pivot element is present at index number 1. Okay. And 5 will be here. So now what do I see? See guys, I was interested in sorting the array from index 0 till index 1, right? And I called my partition function and 7 went to its correct position, right? Now guys, try to understand. When you are running this logic, what was the initial value of L? 0. What was the initial value of R? 1. And what was the partition index that you got after, you partitioned? The partition index also comes out to be 1. Okay? So this element is at its correct position. Now what I will take, I will say, boss, now can I sort the left and the right subparts? This is my partition index. Let us call it PI, partition index. So what will be the left part? See, your partitioning has happened here. And this is L, this is R. Okay. So what is the left part? From index L till partition index -1. देख लो यही कर रहे थे ना? From index L till partition index -1. So when I say, can you sort the left part? I will make a quick sort call to ARR, comma 0, comma 0. L is 0 and partition index -1 is also 0. So this is a single element. Do you have to do anything? No, simply return. Now, once the left part has been, sorted, okay, quick sort sorts the left part. Then I will say, can you also sort the right part? Okay. And what will be the call made for the right part? Quick sort will be called on what? What? This was partition index, right? So from partition index +1 till R. So what is partition index? 1. What is partition index +1? 2. And what is R? R is 1. So I am telling boss, partition index is, the starting of the right part is index 2 and the ending of the right part is index 1. This is not even a valid right part. Because if you see very carefully, if you carefully observe this part, okay, see, this was L, this was R, and the partition happened here. So there is a left part, but there is no right part. Okay. So this is a bad right part. So I will simply return. So when I return from these two, I see that the left and the right parts are already sorted. So from index 0 till index 1 of the main array is now sorted. See. So now my left part of the sub-array has become sorted. The left part of my array has become sorted. Now I will make a quick sort call to the right part. Can you sort this right part of the array for me? Okay. And let me try to make it in more bigger sense so that you understand it. It is 12, 10 and 11. Okay. So the quick sort call will be made on ARR. What is this index? 3, 4, 5. Okay. So this is index number 3, index number 4, index number 5. Okay. So I make a quick sort call on 3, 5. Can you please sort this array from index 3 till index 5? Now what do I do? First of all, see, when this context is running, right? First of all, I know that L is 3, R is 5. So first of all, I will make a call to my partition function. Can you partition? So what will happen? The pivot element will be chosen as ARR of L, which is 12. And then I will make sure this element goes at its correct location. So let's say 12 comes here. Okay. And you get that boss, the partition index is 5. Okay. And let's say 11 and 10 are to this part. Okay. So see guys, this is the partition index. The partition index is this. Okay. This was L. This is R. And this only is the partition index. So now what I will say, boss, the partitioning has happened. Can you please sort the left part and can you please sort the right part? So you see that there is no right part, right? So when you make a call to the right part, quick sort ARR, partition index +1, R. So you will see that the starting index is 6 and the ending index is 5. So there is no valid right part. So the right part is already sorted, right? I just need to sort the left part. So I will make a quick sort call on the left part. And where is the left part? From index L till partition index -1. Bhaiya, dhyan se samjho. If this is a random array from L to R and your partition happens somewhere here, then what is the left part? From index L till partition index -1. And what is the right part? From partition index +1 till index R. So I make a call to quick sort on the left part, which is from index L till partition index -1, 3, 4. Now I'm interested in sorting this part. Okay. So let us try to run this function QS 3, 4. Okay. Now what will happen? Again, first of all, I will call my partition function. Okay. So what will it do? It will choose this element as the pivot and make sure that this element goes at its correct location. Okay. And it will say, boss, the partitioning has happened at index 4. So L is 3, R is 4, and partitioning P happened at index number 4. Okay. Now I will say, boss, the partition has happened. Okay. This is L, this is R, and this is partition index. So the partitioning has happened. But in order to sort this entire part from index L till R, I need to sort the left and the right parts. So what I will do, I make a function called to quick sort. Can you sort the left part from index L till partition index -1? So I will make a quick sort call to 3, 3. That is a single element. Don't do anything. Can you sort the right part? You make a call to quick sort from index number pivot index +1 till R. You see that starting index is greater. Invalid right part. Done. So once these two calls are done, you know that the entire array from index 3 to 4 is sorted. Okay. Now, from 3 to 4 has become sorted. Try to understand. And now what you will do here, you are from QS 3, 5, and the left part is sorted from index 3 to 4. Now you will sort the right part. You will make a quick sort call to the right part, which is pivot index plus 1, which is index 6, comma R, which is 5. So you will see that there is no right part. So this part is also sorted. So now from index number 3 till index number 5, you have 10, 11, and 12. Okay. So this part, the right part has become sorted. Okay, where were we? Think, yeah. So see, we had sorted the left part and then we sorted the right part, 10, 11, 12. So you see that the entire array has become sorted. Okay. Cool. I'll try to write a code also so that you guys are able to better follow. And then I will again do a dry run. Then it will be more clear to folks. Okay. How the partition function is running, we will see a little bit later. But at this point of time, we need to comfort ourselves with how quick sort is running. Okay. So let's say I write a quick sort function, right? Let's say public, okay, static, void, let's say quick sort. Okay, this is QS. And it is taking an array ARR. It is taking an array and it takes two indexes L and R. The code is similar to merge sort code if you see. Okay. So the job of this function is to sort this array from index L till R. So boss, first of all, I will check if L and R are the same. If L and R are pointing to the same index, then you are looking at a part consisting of one element. You don't even need to sort. And if L is greater than R, that means the starting index is greater than the ending index. That cannot be possible, right? So that is an invalid part of the array. So what I will write, if L is greater than equal to R, you don't have to do anything, simply return. Don't do anything, simply return. Okay, this is my base case. Now, you will come here when L is less than R. This is a comment, right? You will come here when L is less than R. That means you have a valid array to perform sorting on. So what you will do? First of all, my job as a teacher is to, select a pivot and send it to its correct location. And all that logic of selecting the pivot and, making it go to its correct position will be done by the partition function. So what do I do? When I come here, the first thing that I will do is I call a function. Let us call it as the partition function. I pass ARR, L, R. Ki, hey partition function, this is the array. This is the part of the array of our interest. Can you choose a pivot and partition the array? And what will the partition function give us? Now let's assume that partition function selects ARR of L as the pivot, makes sure that this element goes at its correct location. And after sending it to its correct location, it will return to me this partition index. So this partition function, after sending the pivot to its correct location, returns to you the partition index. Okay, so just capture it in a variable P. Okay, I know that yes, the array has become partitioned at index number P. Now, once the array has become partitioned at index number P, what I will say? Simply sort the left part, simply sort the right part. Once both the parts are sorted, your job is done. So how do I sort the left part? I will again make a call to quick sort. Hey, quick sort, can you please sort the left part of the array ARR from index number L till index pivot index -1 or partition index -1. Now assume the left part has become sorted. Now once the left part is sorted, you will call the same function on the right part. Hey boss, can you also sort the array from index partition index +1 till index R? And once the left and right parts are sorted, you will say that boss, the entire array from index L till index number R is sorted. Okay, that's the basic code that we have. That's the basic code that we have. How does the partition logic work? We will see it. We will see it. Okay. So I'll just write the code shortly here in the next slide, and then we'll try to do a dry run on an array. Okay. And then we will see how many of you guys are clear with what is happening. Okay. So let me just write it very small. Okay. Just छोटे में लिख रहा हूँ, ठीक है? तो लोगों को समझ में आ जाएगा. If L is greater than equal to R, simply return pseudocode है. Okay. Otherwise, what I will do in partition, okay, it will return to me the partition index. I will call the partition function ARR, L, R. Okay. Then what I will do, once the array has become partitioned, I will say sort the left part, okay, and sort the right part. Once you have sorted the left and the right part, your job is done. That's it. This is a basic code of quick sort. Obviously, we have to write the logic for the partitioning, but this is a very basic code of quick sort. Now let us take an array, right? Let us take an array and try to understand first of all that how it even works, right? So I can take up the same array that we took in the previous example. So 8, 5, let's change some elements, right? 8, 5. छोटा ही लेते हैं, ज्यादा बड़ा नहीं. 8, 5, 6, 7, 10, 12 ले लेते हैं. 7, 12, 10. ठीक है. और एक और एलिमेंट ले लेते हैं. चलो 11. Okay. So this is the array that we have to sort, right? So what are the valid indexes? Let's see. From index 0, 1, 2, 3, 4, 5, 6. Okay. So how will I call my quicksort function? Now let us try to trace it here, right? So from my main method, I will call the quicksort function. I am not writing ARR again and again. From index 0 till index number 6. Can you sort this? Okay. And now what has happened? Just briefly trying to make you guys understand. The context is running. So what do you first see? What do you first see? Is 0 greater than equal to 6? No, it is not. So you have a valid part of the array to perform a sorting on. Okay. So what do? You first of all call the partition function. Okay. So what does the partition function do? It will choose ARR of L and it will make it go to its correct position. So let's assume that once we call the partition function, how does our array look like? Just imagine for now that the partition function works fine. So 8 will be at its correct location. Okay. And let's assume you have 7, 5, 6 here to the left, and you have 10, 12, 11 to the right, something like this, right? And so this has become a partition, and this function will return to me the index. It will return to me the index of 8, which is my pivot, right? So what will be the value of P, guys? P will be 3. That is index number 3 pe mera partition hua hai. Look, index number 3 pe I have done a partition. Now what will happen? I will say, boss, now I will call quicksort on the left and the right part. So what do? I call quicksort on L se lekar pivot index -1. What is L? L is 0. And what is part P -1? 2. So I call a quicksort function from index number 0 till 2. Okay? Now the moment I call, the context gets paused and a new box will be created for quicksort 0, 2. Now this starts running, right? Let's try to follow, guys. Okay. Because if you understand via this, right, then my job will become simple and I don't have to do the dry run after writing the partition function. Okay. So now quicksort on 0, 2 is running. Again, you will see that L is 0 and R is 2. So L is not greater than equal to R. So it's not a base case. So what I will do, I will make a call to my partition function. Just imagine this is your area of interest and you make a call to the partition function. So what it will do? It will choose ARR of L as the pivot. Okay, so 7 ko pivot liya and it will make sure that 7 goes at its correct location in this array. So what will be the correct location for 7? Index number 2. Okay, so if I see here, 7 will come at index number 2. The rest of the array is not disturbed at this point of time. Okay, and let's say you have some logic here, 6, 5. I don't know how, but just take it. Okay. So now the partition is created at index number 2. Okay. This was L, this is R, and the partition has also happened here. So what I will do? Boss, now can you sort the left part? So I will make a quick sort call from L till partition index -1. So from 0 till 1. I will say, hey, can you sort this left part? Okay. The moment you make a call, you will pause here and this new context starts running of quick sort 0, 1. Okay. Now what will happen? You see that L is not greater than equal to R. So you make a call to partition. And what will partition do? It will choose 6 as the pivot. Okay. And it will make sure that 6 goes at its correct location. So 6 will come here. So you have index 0, 1, 7, 8, 10, 12, 11. Okay. And it will tell boss, index number 1 is my partition index. Okay. So L is at 0, R is at 1, and partition index is also at 1. So I will say, boss, okay, the partition has happened here, and this is the ending and this is the starting, right? So can you sort the left part? So I will make a quick sort call on L se lekar partition index -1. So it will be 0, 0. And this will be the base case. You will simply return the left part is sorted. Then I will say, can you sort the right part? ARR, partition index +1, that is 2, R, which is 1. 2, 1. Invalid array, right? Because the starting index can never be greater than the ending index. So you simply return. So when I return from this function context will get destroyed. And when this function context is now destroyed, see guys, at index number 0 and 1, my array has become sorted from index 0 to 1. Okay. Now I come back here, I start playing from here. Boss, from index 0 till 1 is sorted. Now what I will say, can you sort the right part? देखो अब इस context के लिए your partition was at index number 2. This was the partition, right? And the left part is sorted. Now I will say, can you sort the right part? So I will call a quick sort on partition index plus 1, that is 3, to R, that is 2. And I say that, boss, there is no right part, right? There is no right part. So you will simply return and this context will be destroyed. And now you see, guys, from index number 0 till index number 2 is sorted. QS 0, 2 returns. From index 0 till 2 is now sorted. Now what will happen? I start playing again here. From index 0 till 2 is sorted and my partition was at 3. So the left part is sorted. Now I will say, can you sort the right part? And guys, if you have followed, you will understand, right? ये जैसे recursively the left part got sorted, similarly recursively the right part will also get sorted. देख लेते हैं. So I will make a function called to QS partition index plus 1, comma R. So 4 to 6. So I will say, can you sort this part of the array? And once this part of the array is sorted, the entire array will become sorted. So let us try to see. You know, this gets paused. A QS 4, 6 starts running. This is not a base case. So I will call the partition function. 10 is chosen as the pivot. And I see that this is only the correct location of 10. So P is equal to 4. So this is L, this is R, and the partition also happened here itself, right? So now I say, can you sort the left part? So you will make a quick sort call from index L, that is 4, till partition index minus 1. See, 4, 3. Invalid left part, right? Left में कुछ है ही नहीं, देख लो. Invalid left part. There you return. Then you make a call to the right part from partition index plus 1 till R, that is 5, 6. So now my area of interest is this. The boss sort from index 5, 6, right? So now what will happen? You pause here. A new context for quick sort is created from index 5 till index 6. Now what will happen? You again, I call the partition function. So this 12 will be chosen as the pivot and this goes at its correct location. So 12 will come here. Okay. And you will get the partition index as 6. Then I say, can you sort the left part? Left part is from index L till partition index minus 1. So 5, 5, single element, nothing to do. Then you say, can you sort the right part? From partition index plus 1 till R. Invalid part. देखो ना इसके right पे कुछ है ही नहीं, right? So you return. So now QS 5, 6 has been terminated. That means from index 5 till 6 is now sorted. So you come back here. इसके नीचे कोई और line है नहीं. So you return. So from index 4 till 6 is sorted now. You come back here, start playing. There is no further line. So now from index 0 till 6 is sorted. Look at the array. 5, 6, 7, 8, 10, 11, 12. The entire array has become sorted. Now guys, tell me, are you guys understanding what is happening, what we are trying to do? Partition function we will discuss. We will talk about the partition function, but I think this can be the most simplest way of understanding how quick sort is working, right? Okay, I think we have folks that know also. Explain right again. एक मिनट रुको यार, ये create करने का होता है क्या poll? I forgot to create polls today. So let me just quickly get a poll क्योंकि मेरे को ऐसे समझ में नहीं आ रहा है. Not getting the logic for partition because I have not discussed that only, right? Okay. Are you clear with the concept? Let me just quickly have this poll, right? Array yaar. Anyways. Yeah, I'll repeat, right? I just want to see how many folks are understanding even slightly, right? So yeah, if you are greater than 80%, right, that's good. Let's see how many folks are clear. Let's quickly launch it, right? How do I launch it? Folks, can you just cast a vote so that I get an understanding how many of you are able to follow along what is happening? Okay, good. We have great portion. Okay. Okay, so yeah, we have great number of folks who are not clear, so I think we'll have to repeat again for sure. ठीक है, चलो बताता हूँ वापस. Let's come to the PPT. Yeah. So, okay. First of all, forget quicksort, right? I think let's start with the partition function only, right? Let's start with the partition function only, okay. So first of all, what I want to understand is how do I partition? Okay, पहले उधर से ही start करते हैं. I think that will be simpler, right? So let us take a part of the array. Okay, 4. Let's say here you have, 8. Okay, here you have 2. I'm just writing some random elements. Okay, you have 3, 1, 7, 9. Okay, and let's say we have 5. Okay. So this is the part of the array that we are considering, right? So this is index L. This is index R. Okay, from L to R. And first of all, let us try to understand how do I partition. पहले partition logic समझते हैं, ठीक है? That is the most difficult part of this quick sort, I feel. Okay. So let us try to understand how will we partition or what is our partitioning logic. So first of all, मैंने क्या बोला था, guys? That we will always be choosing ARR of L. I will always choose ARR of L as my pivot element. So I choose this element 4 as my pivot element. I have chosen ki boss, this is my 4 and this is the pivot element. Now, guys, do you agree? Do you agree that, after partitioning, your array should look something like this? 4 is here, all elements lesser are to the left, all elements greater are to the right, something like this. This is how the array should look like after you have partitioned. Okay. So the logic that we generally take, okay, I'll try to explain the logic to you all. So we have 2 pointers I and J. Okay. I will start from index L. I को इधर से start करते हैं. And J will be starting from the back. That is from index number R. Okay. There are 2 pointers I and J. I has been initialized to L itself and J is at, R. Now what do I do? Okay. First of all, I will write the points here so that you can understand it more clearly. So first of all, we keep on moving I forward. ध्यान से लिखता हूं, ठीक है? First of all, we keep on moving I forward. Okay, until I get an element greater than pivot. Until I get an element greater than pivot. Okay, so I will keep on moving I forward until I get an element greater than pivot. Okay, then the second step will be we keep on moving J. We keep on moving J backwards. Okay, we keep on moving J backwards until I get an element. Until you get an element less than equal to pivot. Okay, ठीक है. अब हम देखते हैं पहले तो, ठीक है. So guys, first of all, think very carefully. You are moving I forward until you get an element greater than pivot. तो I कहाँ पे रुकेगा? I will stop at an element greater than pivot. Then you move J backwards until you find an element less than equal to pivot. So आपने I को आगे बढ़ाया and J को पीछे move किया. First of all, tell me, do you ever think I and J will point at the same number? Can I and J ever point at the same number? First ये सोचो. पहले तो मैं ये जानना चाहता हूँ. Yes, why? How? What am I telling? I will move forward until you get an element greater than pivot. So I will stop at an element greater than pivot. And then you move J backwards until you get an element less than equal to pivot. So I is pointing at an element greater than pivot or J is pointing at an element less than equal to pivot. So how can they be pointing at the same element? Pehla important point, right? Now let us try to understand what happens. Okay? So I keep on moving I forward until I get an element greater than pivot. So what is my pivot element? Let us briefly write here. What is my pivot element? Is 4, right? So is 4 greater than 4? No. Move I forward. Okay. Is 8 greater than 4? Yes. So I will stop I here. I will stop I here. अच्छा guys, one other interesting point to note is, क्या तुम लोग ये चीज मानते हो? I am moving I until I get an element greater than pivot, right? So to the left of I, all the elements will be less than or equal to pivot. But बोल सकते हो क्या ये? Once I have moved I, can I say to the left of I all elements are less than equal to pivot? क्योंकि अगर कोई element greater than pivot would be to the left of I ना, then I would have stopped there itself, right? So I moved I forward and I came to an element greater than pivot. 8 is greater than 4, so I stop I here. I has stopped here. Now, once I am done with I, what do? I move J backward. ठीक है? I को chance दिया move करने का. Now you will make J move backwards. So till when? I will keep on moving J backwards until I find an element less than equal to pivot. So is 9 less than equal to 4? No. Move J backwards. Is 7 less than equal to 4? No. Move J backwards. Is 2 less than equal to 4? Yes. So J will stop here. So guys, similarly, you will agree that once you have moved J, I can guarantee you all that to the right of J, all the elements are greater than pivot. मानते हो क्या? मानते हो क्या? J पीछे से check करते हुए आ रहे हैं ना, and it stops when you get an element less than equal to pivot. So to the right of J, all elements are greater than pivot for sure. ठीक है? Now once I have given chance to both I and J, ठीक है? I know that I and J can never point to the same element, that is for sure. So once you have moved I forward and J backward, you know what do I see? I see that I is less than J. Okay. I then see if I is less than J, see here guys, I is less than J. इसका मतलब क्या हुआ? An element that is greater than pivot is coming before an element that is less than equal to pivot. Try to understand guys. You are telling boss कि an element which is greater than pivot, let's say your pivot will be here, an element which is greater than pivot is occurring before an element that is lesser than pivot. Is it a correct ordering? Is it a correct ordering? Boss, when you partition the array, all the elements that are greater than pivot will come after all the elements that are lesser than pivot. मानते हो क्या ये बात? एक proper partitioning के बाद all the elements that are greater than pivot are coming after all the elements that are lesser than pivot. But here you see that an element that is greater than pivot is coming before an element that is lesser than or equal to pivot. So what do you do guys? Can you tell me one suggestion? क्या करना चाहिए? मेरे को पता है this relative ordering is problematic. This relative ordering is problematic. 8 can never come before 2. Yes, correct. So if I is less than J, I just perform a swapping. I perform a swapping. ठीक है? तो क्या होगा? 2 comes here and 8 comes here. So now again the conditions are satisfied, right? You do a swapping. Now what I will do? Again, I will repeat the steps. I keep on moving I forward until I, get an element greater than pivot. Okay. And then I will move J backwards until I get an element less than equal to pivot. So again, I keep on moving I. 2 is 2 greater than pivot? No, it is not. Move I forward. Is 3 greater than 4? No. Move I forward. Is 1 greater than 4? No. Move I forward. Is 5 greater than 4? Yes. So I will stop here. Now guys, see, again try to understand. Once you have moved I has stopped here. That is, this is the first element that is greater than pivot. So to the left of I, all the elements are less than equal to pivot. I को मौका दे दिया. Now I will try to move J backwards. Till when? Till I get an element less than equal to pivot. So I start. Is 8 less than equal to 4? No. Move J backwards. Is 5 less than equal to 4? No. Move J backwards. Is 1 less than equal to 4? Yes. So J will stop here. Now you see, is I less than J? No. That means I and J have interchanged each other. So now guys, try to understand. I has come all the way from left. ध्यान से मेरे बात को सुनना. I has come all the way from left and has stopped here. That is, this is the first element greater than pivot. So can I say to the left of I, all elements are less than equal to pivot? है ना? And similarly, J has come all the way from right and has stopped at this one. That means to the right of J, all elements are greater than pivot. क्या ये बात तुम लोग मानते हो? सोच के बताओ. This is the most important part. Do you guys agree that once I and J have interchanged, I can tell you, boss, to the left of I, all elements are less than equal to pivot, and to the right of J, all elements are greater than pivot. So guys, can you help me? Where should I place 4? At what index should I place 4? At what index? I or J? What do you think is the correct location for the pivot? Index I or index J? अब सोच के बताओ. या तो index I पे जाएगा या index J पे जाएगा. Yes, correct guys, J. Because see, if I place my pivot here, I swap ARR of L with ARR of J. So what will happen? 4 comes here, 1 goes here. Now you see, this is my partition. Okay, see, this is the correct location of the pivot. So I will return this index as the partition index. And you can see to the left, all elements are less than equal to pivot. And to the right, all elements are greater than equal to pivot. Okay, let me repeat once again. देखो guys, try to understand. Let's take another example. Pivot is the element that you have chosen. Okay, pivot को आपको अपने सही जगह पे भेजना है. You choose an element and make sure that that goes to its correct position. The element that you choose, that is what I call as the pivot element. Let me take another example. Okay, I'm just interested in knowing how the pivot, how the partitioning is happened, right? So let's say you have this array 4, 3, 1, 2, 8, 9. Okay, this is L, this is R. Okay. So I will initialize. So by default, I am choosing ARR of L. I will always choose ARR of L as the pivot. Okay. So I choose that what is my pivot, boss? ARR of L, which is equal to 4. Okay. So I is here and J is here. Now what do I do? What is our rule? First of all, keep on moving I forward. Keep on moving I forward. Okay. Till you get an element, what? Greater than pivot. Okay. So where will I stop? I will stop at this 8. Okay. Then I move J backwards until I get an element less than equal to pivot. So where will J stop? J will stop here. Now, once you have moved I and J, you see that I and J, I is no longer lesser than J. That is I and J have interchanged. इसका मतलब क्या हुआ guys? I has come all the way from L, all the way from left, right? और इधर रुका है. That means this is the first element greater than pivot. So to the left of I, all elements are less than equal to pivot. And J has come all the way from the right, and this is the first element less than equal to pivot. So to the right of J, all elements are greater than pivot. First of all, tell me, do you agree this part? If I and J have interchanged after the movements, then you can for sure say that to the left of I, all elements are less than equal to, and to the right of J, all elements are greater. So what should be the correct index of this pivot, of this 4? I will say J is the correct index for this 4. So what I will do? I swap ARR of L with ARR of J. So what will happen? 2 comes here, 3, 1, 4 comes here, right? Okay. And I say this is index J, this is index I. So now what I will say, boss, the partitioning has happened at index J. देखो, index J पे partitioning हो गया है. Because if you look to the left of J, all elements are less than equal to pivot. And if you look to the right of J, all elements are greater than pivot. So what will my function return? I will return J. If this is the partition index. ठीक है? फिर से करते हैं, इन दोनों पे भी लेते हैं. ठीक है? Now I'll say, can you partition the left part? Now I will call quicksort on the left part. ठीक है? So let's say you have 2, 3, 1. ठीक है? This is L and this is R. So what I will do? First of all, what is my pivot element? My pivot element is 2. Okay? So my I is here and my J is here. What do I do? First, move I forward until you get an element greater than pivot. I comes here. Move J backwards, इस तरफ में, इस direction में, right? Until you get an element, what? Less than equal to pivot. Okay. See, I will keep on going forward until it gets an element greater than pivot, right? And J keeps on moving backward until it gets an element lesser than equal to pivot, right? So will J move? Will J even move? सोच के बताओ. Will J even move? No, na. J will not move. This one is less than equal to pivot. So now you see that I is less than J. That means an element greater than pivot is occurring before an element less than equal to pivot. So just do a swapping. So 2, 1, 3. Okay? Now I was here, J was here. Now again, keep on moving I forward until you get an element. What? Greater than pivot. Is 1 greater than pivot? No, move forward. Is 3 greater than pivot? Yes, stop. Now you will keep on moving J backwards until you get an element less than equal to pivot. Is 3 less than equal to 2? No. Then J comes here. Is 1 less than equal to 2? Yes. So J stops here. Now guys, try to understand. I has come all the way from index L and stopped here. That means this is the first element greater than pivot. Okay. So all elements to the left of I are less than equal to pivot. And J has come all the way from the right and stopped here. That is, this is the first element less than equal to pivot. So what will happen? To the right of J, all elements are greater than pivot. So I will say this can be index number J can be the correct location for pivot. So I swap ARR of L with ARR of J. So what will happen? 1 comes here, 2 comes here, 3 comes here. And I will say, boss, this is the index of 2C. 2 has been at its correct index, right? Is this making sense? Bhai, kuch nahi kar rahe ho. First of all, you move I until you get an element greater than pivot. Move J backwards until you get an element less than equal to pivot. Now, if I is less than J, iska matlab kya hua? An element that is greater than pivot is occurring before an element that is less than equal to pivot. You do a swapping. Then again, you move I, you move J backwards. Okay. And then again, if I is less than J, you do a swapping. And when I will become greater than J, now, once you move, when I becomes greater than J, then what will happen? What will happen? You know that J is the correct index of the pivot. So you swap ARR of L with ARR of J, and then you can simply return. Okay, job done. How many of you are understanding this partition function? This is an interesting, function. Partitioning function कितनों को समझ में आया है? with greater element at L plus 1. Okay, we'll take another example, but before that, let me just check on you guys. Is this making sense, right? Duplicate. How do I launch it? End this poll. And let's just come to the second one. Guys, can you just say how many of you are clear with the partitioning logic? How do you make sure that an element goes at its correct location? Do we always swap ARR of L with ARR of J? Yes, yes, ARR of J के साथ करोगे ना, because see what happens if you swap with ARR of I, then you might not get a correct partitioning. If you look very carefully, let us look here, right? So let's say if I swap, let's take this example, right? If I swap this 2 with ARR of I, what will happen? 8, 3, 1, 4, 2, 9. Where is your partition created? Is this the partition? No, this is not the partition. Because to the left, you have elements greater than pivot element, right? So this is not a correct partition. So always we swap ARR of L with ARR of J at the end. Okay. Okay. Yes, correct. Okay. So if we look at how many folks are clear, let me have how 2 and 1 swaps. Okay. What is the complexity of the partition function? Can you guys only help me? What is the complexity of the partition function? Anybody? What are you doing? You are just I and J are moving towards each other, swapping, moving towards each other, swapping, moving towards each other, swapping. And the moment they cross, your function terminates. So it is big O of n, right? It is a linear time complexity. Okay. It's a linear time complexity is the partition function. Okay. Okay. So let us write the code for the partition function first of all. Okay. देखो एक और बार बताता हूँ partition function, ठीक है? Just to make sure everyone is absolutely clear. What happens? चलो ले लेते हैं. That's good that you guys are giving me inputs. 4, 5, 3, 2, 1, 8. चलो. I am interested in the partitioning logic, right? I will just show you one partitioning logic. Okay? तो भाई देखो क्या कर रहे हैं हम लोग, right? No, I can't say in Hindi at the moment, right? Because there are many folks who wouldn't understand it. So first of all, we'll do in English only, right? So first of all, this is index L, this is index R. So what do? I choose ARR of L as my pivot. तो मैंने मनी मन में डिसाइड कर लिया. चलो साथ ही में बता देता हूँ. मनी मन में मैंने कर लिया डिसाइड कि भैया 4 है मेरा पिवट, ये है मेरा 4 पिवट, राइट? और मेरे को क्या करना है? आई वॉन्ट टू मेक श्योर दैट 4 goes at its correct location. Okay. So after partitioning, your array should look something like this. कि 4 is there. All elements जो 4 से कम है, that should be towards the left part, and all elements greater than 4 should be towards the right part. ठीक है? तो मैं क्या बोलता हूँ? चलो भैया 4 को भेजते हैं उसके सही जगह पे. ठीक है? So I take a pointer I here. I take a pointer J here at element. Now what I will do? I keep on moving I forward. मैं बोलता हूँ I भाई आगे बढ़ते रहो till when? Till you find an element greater than pivot. जैसे ही आपको एक नंबर दिखे जो पिवट से बड़ा है, रुक जाओ. So what will I check? 4. Is 4 greater than pivot? No. Move forward. Is 5 greater than pivot? Yes, it is. Stop. I को नंबर मिल चुका है जो पिवट से बड़ा है. ठीक है? तो देखो guys, always to the left of I, all the elements will be lesser than equal to pivot. क्योंकि I रुक ही रहा है वहां पे जो नंबर greater than pivot है, तो इसके लेफ्ट में पक्का less than equal to pivot है. Okay. Now try to understand, guys. You have moved I forward. You have moved I forward until you get an element greater than pivot. So to the left of I, all elements will be less than equal to pivot. Now what do? I have got an element greater than pivot ना. अब मैं बोलता हूँ J को पीछे मूव करते हैं. Let us try to move J until I get an element less than equal to pivot. ठीक है? So J will move back. Is 8 less than equal to 4? No, it is not. Move J back. Is 1 less than equal to 4? Yes. तो J को मिल गया एक element that is less than equal to pivot. Now guys, try to understand. I is pointing to an element that is greater than pivot, and J is pointing to an element that is less than equal to pivot. But guys, after partitioning, all elements that are less than equal to should come before all elements greater than. Right? Hello? Am I not audible? Hello? It's full only, I think. Okay. So guys, now try to understand what is happening. Boss, I is less than j, right? So that means an element that is greater than pivot is coming before an element that is less than equal to pivot. And this is not done, right? Because after partitioning, elements less than equal to pivot should always occur before elements that are greater than pivot. That is the nature of partitioning. So just swap these two. So 4, 1, 5, 3, 2, 8. Ho gaya swap, and I is here, j is here. Now, again, I will say move I forward until you get an element greater than pivot. So where will I stop? This time I will stop at this. And then I say move j backwards until you get an element less than equal to pivot. So j will stop here. Okay? Kar diya ye movements. Now guys, try to understand. After you have moved I and j, you see that I is no longer less than j. That means I less than j, hua na boss? This is index number, let's say 1. So this is index number 4. So 1 is less than 4, right? Okay. Now, once I and j have interchanged, right? Then, ab dekho guys, try to understand. I has stopped at an element greater than pivot. So to the left of I, all elements are less than equal to pivot. And j is coming all the way from the right and has stopped here. है ना? So matlab kya hua? This is the first element less than equal to pivot. So to the right of j, all elements are greater than pivot. So can't I say, boss, if I swap ARR of L with ARR of j, basically j can be the correct index, because if you swap, you will get 2 here and you will get 4 here. And I will say this is the partition index. So j is the partition index. Okay. So what I will say, j is the partition index. So you will see to the left of j, you have 2, 1, 3 elements lesser than 4. And to the right of j, you see that you have elements greater than pivot. Ho gaya partition. Making sense? No, I less than j, you are comparing indexes. Okay. Okay. Now yes, we have taken one more class on Quicksort. Let's quickly code up the partition function, right? See, if the partition function is clear now, I would say 70% of Quicksort becomes clear, because after that, it's just the plain simple magic of recursion that you have to trace, right? If partition function becomes clear, it's almost done. क्योंकि यही सबसे ट्रिक पार्ट होता है इसका. ठीक है, फट से लिखते हैं partition function. ठीक है, so public, what should be the return type of the partition function? Can anybody help me? What should be the return type? Okay, we have only 20-25 minutes left, so let us try to do this quickly. The return type will be int, because it is expected to return the partition index back to you. Okay, now what do I do? मैं थोड़ा pause करता हूँ chats को, है ना? Okay, now let us write here partition. This is my partition function. It will take an array ARR, okay, and it will take int r. ठीक है? अब भैया क्या करेगा partition function? What is the partition function expected to do? First of all, you will choose an element as the pivot. What is your pivot? My pivot is nothing but ARR of L. I have chosen ARR of L to be my pivot. Now what do? I initialize pointers, right? Int I is equal to L, right? And int j is equal to R. So अब मैं क्या बोलता हूँ guys? What are we doing? What are we doing for the first time? We are first of all moving I forward until I get an element greater than pivot. So I say while ARR of I is less than equal to pivot, what should I do? I will keep on doing a I++. So when will we come outside the while loop? When I is pointing at an element that is greater than pivot. Now, one thing we all need to understand, guys, let's say, you know, your valid indexes are from L till R, okay? And let us say that, you know, this is the pivot element, okay? And you want to find an element that is greater than equal to pivot, but consider that all elements are lesser than pivot. So what will happen, guys? You compare, you start 8 less than equal to 8, yes, move forward. 2 less than equal to 8, move forward. 6 less than equal to 8, move forward. 7 less than equal to 8, move forward. 0 less than equal to 8, move forward. 0 less than equal to 8, move forward. 0 less than equal to 8, move forward. Now you don't need to do a comparison, right? I chala gaya, I ko aur move nahi karna hai. So here I am keeping a check also, ki boss, you will be checking ARR of I is less than equal to pivot only as long as I is in the valid range. So while I is less than equal to R, this is my valid index range, right? While I is less than equal to R, that means you are in the valid range, keep on checking and moving I. The moment I goes beyond R, you just stop kar do. Okay? So after this while loop, I am expecting that yes, I is pointing at an element that is greater than pivot. Now, what is the next task? The next task is to move j backwards until you get an element less than equal to pivot. So what do I say? While ARR of j is greater than pivot, while ARR of j is greater than pivot, I will do a j minus minus. Okay? So j when will I come outside the while loop? When j is pointing at an element that is less than equal to pivot. So now, guys, I have a very quick question for you, right? Let's say, do you need to keep a check j greater than equal to L? तुम बोलोगे ना भैया, do you also need a check कि j is coming from R till L? So the valid index for j should be till L only. It should not go to the left of L. But do you think j will ever go to the left of L? Do you need to have an explicit condition check for j? No. Why? Because see, when the value of j will be equal to L, now what you will compare? ARR of j greater than pivot, that is pivot greater than pivot, and that will be false, है ना? जब j की value L हो जाएगी, so j is pointing at the pivot element only. So you compare, is 8 greater than 8? It is false. So you will come outside. So j automatically will be in the valid index range only. If you want, you can have a safety check, but it is not required, right? It is not actually required. Okay, not required. Okay. Now you have moved j also back. Right now, what do you check? After you have moved I and j, what do you check? You check if I is less than j, what do you need to do, boss? What do you need to do? You need to perform a swapping. You need to perform a swapping. What? ARR of I with ARR of j. So let us take a temporary variable equal to ARR of I. Then let us take ARR of I is equal to ARR of j. Then I will say ARR of j is equal to temp. So I have swapped ARR of I with ARR of j. Okay. Now, guys, tell me, once you have swapped, क्या करना था मेरे को? I have to run this same piece of logic again. Do you agree? ये same piece of logic ही मेरे को वापस से run करना है ना? Again, I want to move I forward until I get an element greater than pivot. Again, I move j backward. I have to repeat this same logic. So till when will this logic be repeated? Till I is less than j. The moment I becomes greater than j, you need to stop this logic. Okay. So what do I do, guys? I put it inside another while loop. While I is less than j, you will have to keep repeating all this logic. अंदर डाल दो. Okay. So see what will happen now. I'll just show you 1 second. Now try to understand, guys. I less than j, you move I forward, you move j backwards. You compare. If I is less than j, you will do a swapping. Then again you come to this while loop. I is less than j. So again I will first move I forward, move j backward. Compare. If I less than j, do a swapping. Okay. Then again you will come and check I less than j, move I forward, move j backwards. Check. If I is less than j, do a swapping. Okay. Again you go and check I less than j, move I forward, move j backwards. Now, suppose I has become greater than j. So you will not enter inside this if block. No swapping is done, right? Then you come again to the while loop, but this time you will see that I is greater than j. So you will come outside the while loop. So can I say I will come outside the while loop when I is greater than j? Yes. And when I is greater than j, can I tell you what should I do? I should swap my pivot element with ARR of j. So what is my pivot element captured in this variable? So let us do ARR of L, right? I should ideally swap ARR of L with ARR of j. So ARR of L में मैं क्या लिखूंगा? I will write ARR of j. Okay. I will take the contents of ARR of j and put it in ARR of L. Okay. And then what I will do? Can anybody tell me the next line of code that I write? एक line. One more line. Can anybody help me? ARR of j पे क्या लिखूं? ARR of j पे क्या लिखूं? भाई return देके पहले one more thing, right? You need to make sure that the pivot is present at index j, right? So ARR of j is equal to pivot. So by this, we have in a sense swapped ARR of L with ARR of j. And now I know the pivot is at its correct location. So let me return the index of the partition, which is index j. Okay. How many of you are clear with this partition function? Making sense? समझ आ रहा है? Line 38 and 39. 38, 39 is nothing. Once you come outside the while loop, you know that I is greater than j, right? I is greater than j. So what happens? You simply swap ARR of L with ARR of j. Okay. So see, I have already done na. Int pivot is equals to ARR of L. Backup ले लिया इसका. Then I say ARR of L is equal to ARR of J. Then you say ARR of J is equal to pivot. Swap कर दिया. And then I have returned the index of the partition. Okay. Line 21, why a new while loop? Because guys, try to understand what am I doing. If you try to simulate the logic, now you will understand. Let's say you have 8 here, 2, 3, let's say 10, 12. Okay. So let's say you have I here and you have J here. So I see I is less than J, I enter. So first of all, I need to move I forward till I comes at an element greater than pivot. So I will stop here. Then I will say move J backward until you get an element less than equal to pivot. So J stops here. ठीक है? ये तो थोड़ा अलग केस हो गया. Just 1 second. हाँ, ठीक है. So now I see if I is not less than J, so I will again go and check is I less than J? No, I will come outside the while loop. So I come outside this while loop when J is greater than I. So what I will do? I swap ARR of L with ARR of J. That is the correct partition. And why do I have this while loop? It is because guys, try to understand. You had I here, you had J here. You moved I forward, you moved J backward, right? Let's say I is pointing here and J is pointing here. So if I less than J, I did a swapping. But after swapping, I again moved I forward, moved J backward, right? So I had to repeat this job. Entire thing I had to repeat. How many number of times? Till I was less than J. The moment I becomes greater than J, you don't need to run this logic. You come outside and you just swap ARR of L with ARR of J. Okay. Okay. Why if I less than J, we are anyways required. Yes, but try to understand, right? If, see, you are, देखो, तुम यहाँ पे check किए, see, try to understand. You checked here that I is less than J. ठीक है? तुम यहाँ पे देखियो कि I is less than J. Then you moved I forward. Let's say I came here. You moved J backward. Let's say J came here, right? So after these two loops, it might be so that J becomes, you know, lesser than I, or I becomes greater than J. That is why यहाँ पे check कर लिया वहाँ पे से. Okay. Cool. Let's have a look at why is I less than equal to R required? Because otherwise, what will happen? I can go outside the valid index range, right? Line 24 and 27. So first this while loop will be completed and then you will go to this while loop, right? No problem. First you move I forward. यही तो हम लोग कर रहे थे. First move I forward, then move J backward, then check that if I is less than J, do a swapping. Then again see, while I is less than J, again do this logic. Okay? Cool. Let me go to the, let's check out how many folks are clear with this. I don't want to spend too much time, otherwise we'll not be able to talk about the test things. So launch नहीं किया क्या ये? Duplicate कर देता हूँ. 1 second. 1 sec, guys. 1 sec. Let's launch it. Yes, guys. Can you just cast a vote of how many of you are clear with the partitioning logic? At least try to do a dry run. You will understand what is happening. Just vote honestly, right? Dry run. Okay, let me do a dry run once again. Chalo, theek hai yaar. ठीक है, so I'll spend some more time on partitioning function, right? But then ठीक है, quick sort कल थोड़ा करा दूंगा. चलो कोई बात नहीं, कर लेते हैं partitioning function. Let's do a dry run on the code, right? I think that would be the best to make you guys understand where is our code. अच्छा, give me an array. Give me an array. Give me an array. Give me an array. We'll try to do a dry run, right? 5, 4. यार एक मिनट रोकना पड़ेगा, चैट बहुत आ गया. Okay, 4, 6, 12, 5, 7. चलो ले लेते हैं. So you have, let's 4, 6, 12, 5, 7. ठीक है? Okay. So my L is here. Okay. And R is here. Okay. So what do? I initialize I equal to L and J is equal to R. Please try to follow the code, right? Please try to follow the code. ठीक है? तो अभी हम लोग देखते हैं. अब देखो guys. What are we doing? I first come here while I is less than J. Is I less than J? Yes, it is. So what I will do? देखो boss, पहले मैंने check किया I less than J, right? So what am I doing? First of all, I will start running this while loop. While I is less than equal to R and ARR of I is less than equal to pivot. Is I less than equal to R? Yes. Is 4 less than equal to 4? My pivot is nothing but, if I write here, pivot is equal to 4. Okay. So ARR of I is less than equal to 4. I will do a I plus plus. Again, I check. I am in this while loop itself. I less than equal to R? Yes. Is 6 less than equal to 4? No, it is not. So you will come outside the while loop. I come outside this while loop. That is, I am done moving I forward. Okay. Next, what I will do, I want to move J backwards. देखो guys, जब मेरे को पता I less than J है ना, see, before even running these operations, I knew that I is less than J. So once I is less than J, I know that I have to move I forward and move J backward. तो पहले मैंने I को forward move कर दिया. Then this while loop will start running. While ARR of J is greater than pivot. See, is ARR of J is 7 greater than 4? Yes, it is greater. So I will do a J minus minus. Okay. Now, is 5 greater than 4? Yes, I will do a J minus minus. Okay. Is 12 greater than 4? Yes, I will do a J minus minus. Is 6 greater than 4? Yes, I will do a J minus minus. Now try to understand, guys, why didn't I have a condition for J greater than equal 12? Is 4 greater than 4? No, 4 greater than 4 is false. So I will come outside this while loop. So I have moved I and J forward. I have moved I forward and I have moved J backward. Now it is time for me to check what is the position of I and J. So I check. Is I less than J? Definitely not. Definitely not, right? So I know that, boss, now to the right of J, all elements are greater than pivot. And to the left of I, all elements are less than equal to pivot. Okay. So I again, first of all, I is not less than J. So I come again and go back to the top while loop. While I is less than J. Is I less than J? No, I is not less than J. See, ideally you could have an else here and break. Okay. Ideally you could have a else here and break. Ki boss, I greater than J, matlab break kar do. But why have I not done that? Because see, when I check I less than J, it is not true. So you will again go back to the loop. You check, is I less than J? No. So the loop will be terminated. So I come outside and I see I is greater than J. So what will happen? I will swap ARR of L, which is my pivot, with ARR of J. So 4 will get swapped with itself and you will return the value of J, that is 0, as the pivot. Okay? Let's say I am also doing for this part. Abhi pura example le lete. Let's say you have 6, 12, 5, 7. Now I want to partition this, right? This is L and this is R. So what do I do? First of all, I take my pivot equal to 6. Okay. Now what do I do? I is here, J is here. So first of all, I will check. First of all, I check. I less than J? Yes. So देखो, I less than J hai, so I know I need to move I forward and I need to move J backwards. So I'll say, while I less than equal to R. Is I less than equal to this index? Yes, it is. So, and yeah, is 6 less than equal to 6? Yes, move forward. Okay, I less than equal to R? Yes. Is 12 less than equal to 6? No. So I will come outside this while loop, move I forward. Now I will move J backwards. Okay. So while ARR of J is greater than pivot, is 7 greater than 6? Yes, it is. Move J back. Is 5 greater than 6? No, it is not. Right. So I see that yes, more done moving I and J. All right. Now I check, is I less than J? Yes, I is less than J. That means you need to do a swapping. So I make 5 come here. I make 12 go here. Did a swapping? Now guys, try to understand the importance of this outer while loop. Aapne swap to kar diya, but still I is less than J, right? So you might want to still move I forward, move J backward. Aapko same operation continue karna hai na. So you again go to the top while loop and check I less than J hai, enter inside. Move I forward until you get an element greater than pivot. Where will I stop? I will stop at this 12. Then I will move J backwards until I get an element less than equal to pivot. So J stops at this 5, right? Then what do I do? Then I will compare I less than J. No, I is not less than J, right? So I just go to the next iteration of the while loop. I not less than J, I will come outside the while loop. And I know that J is the correct index for pivot. So I will swap ARR of L with ARR of J. So 6 comes here, 5 goes here. And I say that, yes, this is the partition. See, all elements greater than 6 are to the right. All elements less than equal to 6 are to the left. Is it making any better sense now? Is it helping? कितने लोगों को समझ में आ रहा है क्यों क्या हो रहा है? Yes, better. Okay, so it's 82-18. That's great. And okay, so you understand this thing, right? सोचना थोड़ा, ठीक है? Try to think what is happening. Try to do a dry run yourself. Now, if you don't do a dry run yourself, it would never be clear, right? But हाँ, एक बार खुद करो तब और अच्छे से समझ में आएगा, ठीक है? So now let us quickly, what's the time? It's 9:12. Acha guys, ठीक है. So now let's go back to our quicksort discussion, right? अब आप मेरे को पता है partition कैसे होता है. I know how the partition happens, right? So let us write the code for quicksort also first. इधर ही top पे लिख देते हैं, ठीक है? So let's say I'm writing a function public static void qs quicksort, right? It will take an array arr, okay, comma int l, comma int r, ठीक है? Now first of all, what I will check, if l is greater than equal to r, that means either the part of the array that you want to sort consists of only one element, or you are not even looking at a valid part of the array. So simply return. Don't do anything, right? Otherwise, you have a valid array to sort. तो मैं सबसे पहले क्या बोलता हूँ? First of all, I will say, hey, please partition the array. Please partition the array. ARR, LR. It will partition. It will choose ARR of L as the pivot, create a partition, return to you the partition index. Then what you will say? Once the array has been partitioned, I will say, hey, can you please now quick sort the left part? Please sort the left part from index L till index partition -1. Okay. And then I will say, can you quick sort the right part from index partition index +1 till index R. And once the left and the right parts are sorted, I will say the entire array has become sorted. That is the logic for quick sort. Okay. Let's quickly do a, take an array and see it's working fine or not. 9, 2, 7, 6, कुछ भी ले लो यार. ठीक है, let's take this. And let's call a QS ARR, comma 0, comma ARR dot length -1. Okay. And let's convert the array into a string and print it for convenience. Arrays dot toString ARR. Okay. And let's import java.util.start. Okay. Let's try to run it and see how it goes. So reach the end of the file. Okay. We have missed a bracket, I feel. सही है. हाँ, इसका bracket छूट गया ना. ये bracket किसके साथ है? Wait, let's put a bracket here. Okay, see, the array has become sorted. And if you want to take an odd, ये कितना even था? So if you want to take an odd sized array, let's take a 15 here maybe. Okay, let's try to run it. Okay, so it's getting sorted, right? It's getting sorted. Okay, so let me just quickly make you guys go through the quick sort method, right? And analysis, I think I'll spend some time tomorrow maybe, because today I want to discuss about the test. That is important, right? That is important. Okay, so let's quickly talk about the coding logic, right? So now I think folks should be able to understand what is happening. We'll take a very small array and try to do it, right? Not a very big array. So let's take 8, 7, let's say take anything here, 10. Okay, and let's say take anything, ले लेते हैं 15 ले लेते हैं, ठीक है? So this is the array that we have to quick sort, right? This is the array. So yeah, एक दो element और ले लो यार, ठीक है? This is the array that we have to quick sort. So what I will do, I will call quick sort 0, 5. Now guys try to understand, right? So first of all, what I will say, I will call the partition function on 0, 5. So what will happen? The partition function works, and what will happen, guys? It will choose this as the pivot and make sure that 8 goes at its correct location. So let's say 8 is here, you will have 15 and 10 somewhat like this. I don't guarantee how this will be, but 8 will be here, and here you will have 7, 2, 5. Okay? And it will return this index, which is index number 3. So I see that yes, the partition index is 3. Then what I will do? Then I will make a call. See, this element is at its correct location, right? So I say, can you quick sort the left part of the array from L till partition index -1. So I make a call to quick sort 0, 2. Now let us try to understand this part. I'll try to make separate arrays to make you guys understand. Okay? Now I am on quick sort 0, 2. So again, first of all, I call the partition function. this 7 will be taken and this will go at its correct location, right? So 7 will come here. Okay. 5 and 2 here. Okay. Now what will happen? What is the partition index? Partition index is 2. So I will say, hey, now see guys, index 2 is containing correct element, index 3 is containing correct element, right? Try to understand. Now I will call quicksort on the left part. Yeah, partition tha. Let us call quicksort on the left part. So what is the left part? From index L till index partition index -1, from 0 till 1. I have called quicksort on the left part. Let us try to follow. 5, 2, 0, 1. I have called quicksort on this, quicksort 0, 1. Again, I call my partition function. So 5 will be taken and settled at its correct location. Okay. So 0, 1 and index number 1 pe 5 hai, and this is my partition. So now what do I say? Can you sort the left part? What is the left part? Quicksort of L se lekar partition index -1. That is 0, 0. Single element, return. Left part is sorted. Right. This is also sorted. Right part. Is there a right part of this array? For sure, no. Because you see from partition index +1, which is 2, till R, 2, 1. Not a valid right part, right? So done. Now we will say that from index 0 till index 1 is sorted. See, from index 0 till index 1 is sorted, right? I'm circling it just to make you guys understand, right? Okay. Now from index 0 to 1 is sorted. That is, this left part is sorted, right? Yahan pe 2 and yahan pe 5 hai. Now what I will say, can you sort the right part? So what call I will make? Can you sort from partition index +1, that is 2 + 1 is 3, till R, which is 2. Not a valid part, return. Now you say that, boss, from index number 0 till 2 is sorted. Dekh lo, you have 2, 5, 7. See, 2, 5, 7. From index number 0 till 2 is sorted. 2, 5, 7. 8 is already here. Now I will say, boss, now again you are in quick sort, 0, 5. This part is done. Now you make a call to the right part. Can you sort from partition index +1, that is 4, till R, which is 5? Can you sort this right part? Okay. Then again, what will happen? This function context starts running. Okay. So अब क्या होगा, guys? Try to understand. Quicksort of 4, 5 is running. I'll call my partition function. So 15 will be taken and it will come here. 10 comes here, and this will be returned as the partition index. So partition index will be 5. Now I will tell, can you sort the left part? You will make a quicksort call from L till partition index -1. Single element sorted. Can you sort the right part from partition index +1 till R? No valid array, sorted. Now see, after this, the entire array is sorted. 2, 5, 7, 8, 10, 15. Is it making sense? Yes? कितने लोगों को समझ में आ रहा है क्या हो रहा है? See, it's a little bit tricky to follow quicksort, right? And to be very honest, when I did coding for the first time, I'll be very honest with you, I didn't understand the partition function. मेरे को नहीं समझ में आया था, ठीक है? और उस समय I was not very clear for sure, right? But once it clicks to you now what is happening, then you never forget. Like it happened to me while coding. Suddenly I understood what was happening. उस दिन नहीं समझ में आया, but 2-3 दिन बाद ऐसा चमका कि हाँ, this is why it is happening. And then once I understood that, now I never forgot after that. Okay. Cool. Not clear with quicksort. Okay. So guys, I'll share some YouTube videos with you also, right? So you can try to, first of all, I will suggest you all to first understand the partition function. Once you are clear with the partition function, try to, run the code of quicksort yourself. एक बार खुद से pen paper पे context बना के trace करो recursion को. Try to trace recursion by making context. If you still don't understand after that, I will share a couple of links with you, one in Hindi, one in English. You can try to watch the YouTube videos. They are also very good. Okay. So you will definitely, understand. Okay. Okay. So time and space complexity discussion, I think I'll postpone to tomorrow. Okay. So now let's drop the quick code. I'll drop it in the, the doc, the Google doc. Okay. Okay. जिसका समझ में आए, right? You have many folks making videos, so you can try to watch any one of you. Okay. I'll share the video links of Abdul Bari. He's a good explainer in these. And you can also, I'll also share like a Hindi one. That is Anuj Bhaiya ka, it's good. The videos are good, right? Otherwise, देखो जिसका जिससे comfort हो, whatever you guys feel comfortable in. My basic idea is in class, you should be at least 60 to 70% clear of what is happening. If you are 60 to 70% clear for the first time when you look quicksort, then when you spend time yourself, it will definitely increase to 80 to 90%. And then it will slowly increase to 100. Okay, give time to yourselves, you will definitely understand. Okay. Okay. Now, strings thoda bata dijiye. Yeah, we will do strings tomorrow. We will try to take strings matrices tomorrow and day after tomorrow. We'll do some solving problems, right? But now let us come to some discussion of the exam, right? I have certain pointers, okay? And I'll first of all, don't spam the chats at this point of time. I don't want to turn off the chats, okay? So let's not write anything in the chats at the moment. I am, sharing some pointers with you all, right? Some very important pointers that are essential for you in the test. Okay? Wait, I had them somewhere. मेरे को खोलने दो, मेरे को भी याद नहीं है. Just 1 second. Yes. Just give me 1 sec, guys. Yeah. Okay. So let's start discussion right now. The entire next 30 minutes, it's all about your module flow, and it's very important for everyone to understand. Okay. So I'll go very slowly. हाँ, मैं बताऊंगा. I haven't done the analysis, right? The time complexity, space complexity, stability, adaptiveness, that is pending. But I thought that अभी test का discuss करना is ज़्यादा important. And tomorrow when we have time, I'll spend 30 minutes on this more. Okay. And then we can take up questions. Okay. So the first thing is, everybody knows that your test is on. Yes. This is our test date. Okay. I'll stop the charts. I'll stop the charts for the moment, right? So this is the date of your module test. Okay. The test window will be from 9 p.m. to 11 p.m. If you want to make notes or jot down the points, you can. I am going very, very slowly. I'll cover each and every point in detail so that it's clear to all of you. So the test window is from 9 p.m. to 11 p.m., right? You can start anytime in this window. You can start your test anytime between 9 p.m. to 11 p.m. on 30th of August. Okay. The test is on a platform which is named by Metal. Okay. Platform Metal hai. And Metal is a very good platform for test, right? It's a good proctoring, trust me. मैंने जब अपने कॉलेज में दिया था internship के exam, so it was somewhere on Metal, and it's a good platform. It's a decently good platform. I agree. Okay. Then the third important point, the third point is, you will have function completion problems. You don't have to take inputs. You don't have to print to the screen. You will have function completion problems like we have already discussed. I will share some more practice problems with you. But we have already discussed the function completion approach, the standard leet code format that will be asked in the test. Okay, so you will have a function definition. This is the input, this is the output type, and you just have to code the logic of the function. That is the pattern of the test. Okay, now the fourth point is the syllabus, right? The next question comes, what is my syllabus? So everything that you have done, everything that we have done in module 1, except for recursion, everything that we have done is there in the module course, okay, in the syllabus. So when I rule out recursion, automatically merge sort and quick sort also get ruled out. Okay, that is for you to figure out. But officially what we state is, all the topics are there apart from recursion. Recursion को छोड़ के सब कुछ आपके test syllabus में है. It's there in the syllabus. Okay. Now, what is the total test time? What is the total test time? The total test time is 1.5 hours. Okay, I'm going very slowly. If you want to make notes, you can. Okay, so the total time is 1.5 hours. Okay, and the total marks of the test is 240 marks. 240 marks ka test hai. Okay, and the division has been done that you will be getting 3 questions. You will be getting 3 coding questions in the test. The first one has full marks as 40. The second one has full marks as 80, and the third one has full marks as 120. So this makes total of 240. And in order to pass the test, you have to score at least 60%. That is this. Guys, try to understand, right? We can't keep the pass percentage as 33%, right? So college or school mein hota hai, we can't do like this, right? Because our end goal is that you should be getting placed, right? And placement ke liye you need to be clear with the concepts. So अगर मैं अभी ऐसा कर दूं कि no, you do just 2 questions, I will let you pass, or you just do 1 question, you will move ahead. It will not help you in the long run. So that is why the passing percentage has been kept as 60%. So that if you obtain this 60%, this is the passing marks. So what is 60% of this? 144 marks. 144. This is the passing marks. Okay. So now, I saw that there were many discussions on Discord, right? We have labeled the question as easy, medium, and hard. Okay. But as per the discussion that we are having, right? The first 2 questions are very simple questions, right? The first two questions, everybody should be able to do that. Hint भी दे देता हूँ, चलो. The first two questions will be on the topics that you have already done in the pre-course. Okay. So they will be pre-course level thing. Whatever people have covered in the pre-course, basic for loops, right? Single loops, nested loops, arrays, strings, basic things. Okay. 2D arrays. If you are clear with basic for loop, nested for loop, arrays, 2D arrays, strings, the first two questions are going to be very simple. Pre-course level questions रहेगा. Simple रहेगा, ठीक है? If you are clear with the fundamental concepts, nobody should get stuck in the first two questions. Very, very simple. Now come to the third question. I saw that some people were discussing that there should be an alternative. But guys, try to understand this third question is the only question via which we will be able to understand how much you understand the concepts of the module. And when I say this is hard, this is not actually hard, right? This question will involve some concept that you have learned in module 1. राइट कुछ ऐसा कॉन्सेप्ट जो आप पहली बार मेन बैच में सीखे हो ना, दैट विल बी यूज्ड इन दिस क्वेश्चन. ओके, देखो आई एम नॉट सेइंग एनीथिंग डायरेक्टली बट यू अंडरस्टैंड, राइट? दीस टू विल बी बेसिक क्वेश्चंस and this will be a slightly on the higher level, right? So you will have to use some other concept that you have learned and after that some logic or vice versa, right? So this will be a little bit on the higher side. It will not be that difficult. And guys, try to understand. Ideally, you should be done with these two questions in 40-45 minutes. So you have 40 to 45 minutes for this entire question. And if you have understood the module correctly, you will definitely able to, and see, we are not selling that solve this 100%, right? Even if you are able to solve a few test cases, if you get, let's say 30 to 40% test cases also done of this question, you get the passing marks, provided you have solved these two questions. ठीक है? ये दो क्वेश्चन तो आपको करना ही है. उसके बाद दिस क्वेश्चन, इफ यू आर एबल टू डू इट पार्शियली, यू कैन क्लियर द टेस्ट. ओके, एंड दिस क्वेश्चन ओनली विल जज बेसिकली व्हाट ऑल यू हैव लर्नड, प्रोवाइडेड यू आर एबल टू डू बोथ ऑफ देम. इफ यू गेट स्टक इन एनी वन ऑफ दीज, देन तो देयर इज how do you get one for either? You see, this question is compulsory. You have to solve some part of this question. Okay, we understand by a 144 pass marks. ठीक है, but this is not hard. ऐसा मत सोचो कि hard है. It is on the higher level a little bit, but वैसा भी hard नहीं हुआ. जैसा अपने लोग लीड कोड से किए है ना टेस्ट क्लास में, what type of questions we have taken, it might be on that, right? The maximum capacity of the bags that you can fill, somewhat on that level, if I have to tell you the level, right? So it's not that difficult, but you have to use your brains here and you have to apply some logic. So that is the test format. Okay, now the test will be proctored. Okay, you will have your webcams on and your microphones on. Okay, and my utmost suggestion for you all will be, don't try to cheat. Okay, because if you are caught in the proctoring, we are not listening to any excuses. You repeat module 1 again. If you are caught cheating, you don't have a way out, you again have to repeat. Okay, and see guys, if you cheat now, you are not cheating us. तुम अपने आप को cheat कर रहे हो because you want a job at the end of the day, right? So you should be clear with the concepts. When I say 60%, इतना concepts आपको आना चाहिए so that you can understand the concepts of module 2. If you are not clear with the concepts of module 2, you do a cheating and somehow you don't get caught in the proctoring, it won't help you in module 2. You will see that you don't understand stuff of module 2. So the test is proctored. And high chances is if you are cheating, you will get caught. But again, we Indians can innovate many new methods of cheating. So there can be cases where the proctoring might not be able to catch you, right? But I am telling everyone, अपने आप से honest रहो and don't try to cheat because this won't take you very far. Why? I will tell you later. So if you try to cheat, the test will end as it is. उसी moment पे test will get terminated. So please don't try to cheat. Okay. Now, the students who fail in this module 1 test, right? Suppose you gave the test and you failed. What happens after that? You will repeat module 1 again. You will again repeat module 1. Okay. And why we are making you repeat module 1? Because it is very important that you are, clear with how to use loops, how to use arrays, how to use 2D arrays, how to use strings, what is sorting. If you are not clear with these basic fundamentals now, there is no point you will be able to understand the concepts of module 2. So it is done for your well-being so that whenever you pass a module and move on to the next module, you are clear with the concepts of that module. Okay. So this is all about the test. Anyone has any questions here? Then I will go to the mock interview part. Anyone has any questions? इधर तक में किसी को कोई question है? Any questions? अरे भाई इतना बड़ा question ले लिया. Sir, the platform where we will give exam is only to write the function. There is no night to night input. We think it is easy. If the same. Can we do rough work? Yes, you can do rough work. You can use pen and paper for sure. Searching methods can linear search can be there. Linear search, that is not even a big algorithm. No theoretical question. No theoretical question. Okay. Sir, there will be total 3 questions. Only 3 coding questions, right? This is repetitive, right? You don't have any MCQ. Bhai, बहुत questions आ रहे. How do I take these many? All the 3 topics. 1 second. Can we make it into a Q&A session? That will be easier for me. How do I make it? I don't know. किसी को पता है क्या? How do I make Zoom as a Q&A? What is cheating according to Proctor? If you say something, then And see, guys, किसी का internet issue आ रहा है, something of that is coming, then for sure, right? If you are getting terminated in between because of some genuine reason, there will be some provision for those candidates, right? 1 second, guys. I am not able to read your questions only. So many. Wait. I stop the chats. Can't take so many questions. Pause kar lo. Can we create another function in LeetCode format? If you want, you can. If you don't want, you don't do. Okay. Can we directly solve the hard question first? I think yes. मेरे को नहीं पता, but हो सकता है, कर ही सकते हो. ठीक है. Bubble sort in syllabus, sorting in syllabus, only function, not a full code. Yes, correct. Please allow mic. We will do it later. Will the score be determined from the test cases too? Yeah, it is the standard pattern, right? Let's say you are able to pass 6 test cases, so you get score proportionately, right? कि भैया अगर 10 test case है and the marks is 100, so 1 test case the marks is 10. So there is something like that. Okay. No, you can do rough work. I don't think that will do. Failing in module 1 is not so bad. If you fail, you will repeat it again. Your base will become strong. Okay, that's good. Yes, okay. Any hard level questions have not been done so far. Samar, जो LeetCode पे question किए ना 1-2, those are good questions, right? The questions that we solved on LeetCode, they were good questions. Okay, the sorting one that we did that, right? That was the hard question only from the test perspective. Okay. Please provide some hard questions. Okay, we will provide some sample questions for you all to solve so that you understand better. ठीक है, चलो यहाँ तक मैंने ले लिए सारे questions. Now let us come कि okay, you clear module test. Okay, you clear module test. अब आता है और थोड़ा important part. ठीक है. Now we have seen cases before कि people have cleared the module test via cheating. ठीक है, कि लोग cheating करके module test clear किए. We have seen these cases before. ठीक है. And definitely we want to minimize on these things, right? You shouldn't be passing the module test by cheating, or you shouldn't be passing the module test by any other unfair methods. So what happens? After you give the test and you pass, right? So you go to module 2. Okay? Now I come to all the folks who have passed the test. Suppose कर लो आपने pass कर लिया test को, so what happens? You go to module 2. Now what will happen is, in the starting of module 2, okay, you will be giving a one-on-one interview. Okay, you will be given a one-on-one mock interview. You will engage in a one-on-one mock interview. Who will take your mock interview? An AccioJob mentor will be taking your interview. So there will be a one-on-one mock interview that you have to give in module 2. What will be the topics of this mock interview? Acha, this mock interview will be conducted once you are shifted to the new module after the test. मतलब आपने एक बार मॉड्यूल 2 स्टार्ट कर लिए ना, then only the mock interviews will start. So mostly the date of these mock interviews will be 2nd September onwards. Okay, so 2nd September onwards your mock interviews will start. So you start the contents of module 2. Parallelly, you will have one-on-one mock interviews. Mentors will be taking them. From 2nd September, this interview will start. Okay, now what will be the topics of this mock interview, you will ask me, right? So there, what will be there is, you will be asked coding-based questions. Okay. First of all, coding-based questions will be asked. Okay. And theory-based questions also will be asked here. Okay. Ab dekho guys, we want to make sure that when we are in the mock interview now, we want to make sure that you are fundamentally clear with the concepts of module 1. So we will check the coding concepts for sure. वो तो check करना ही करना है. Here we also check your theory-based concepts. कि ठीक है, time complexity हो गया, space complexity हो गया, small questions कि what is the time complexity of bubble sort, what does bubble sort actually do, just these small questions, right? So some theory based questions from the topics that you have covered in the module that will be asked. But to make things simple for you, for the mock interview, again, recursion is not there. Recursion is not there in the syllabus. Okay. So in the mock interview also, the interviewer won't ask you any recursion based thing or any question that, you know, allows you to use recursion. कोई ऐसा question नहीं पूछेगा. So what you will be asked in this thing, there will be 2 coding based questions. The interviewer will ask you 2 coding based questions that you have to solve, and he will ask you some theory based questions, right? The topics are all the topics that we have done in module 1 except for recursion. Okay. So this will be asked in the mock interview. Now, very, very important things for you to understand. How will the interview be judged? How will you be judged on the interview, right? How will the mock interview be judged? Or how should you give that interview, right? It is very important, right? How will the mock interview be judged? So there will be a full marks of 10. Okay, there will be a full marks of 10. And out of this 10, you will be graded. And what is the pass percentage? कोई guess कर सकता है? Looking at the patterns that we have been doing, what is the pass marks? Guess करो भाई. 6, correct? I think everyone understands. Okay. So the passing marks will be 6. You have to score at least 6 points in the mock interview. 60%. Again, see, we are not making it too large कि 80% and 90% आप score करो. But again, 60% is something that we expect from all the folks here, right? So 6 marks you have to score out of 10. Okay. Okay. Let me just go point by point. Otherwise, I will only forget. Okay. So I have covered this thing. Okay. Now, how you will be judged, right? What all are the parameters on which you will be judged? Okay. So let me write. So the first parameter on which the interviewer will evaluate you is the approach that you have taken for the solution. Ki boss, what is your logical, algorithm building skills, right? So what is the approach that you have taken? आपने कैसा approach लिया है? What is the logic that you are thinking of? First of all, the interviewer will evaluate you on this. Ki boss, whether you are thinking correctly in the right direction or not. Okay, he has given you a question. What is the approach that you have taken? What is the logic that you have taken, right? First of all, he evaluates you on the approach. ठीक है? पहला evaluation रहेगा कि what is the approach that you have taken. You can write these points down if you want. The second approach will be obviously the code that you write, the code evaluation, right? So the code that you write, how good you are writing a code, how well you are able to convert your logic into code. So second thing the interviewer will look at is your code. What is the code that you are writing? And guys, this is generally true for any company interview that you give as well. The mock interviews that we try to take here, we try to replicate them as close to the company interviews as we can. Okay. So think of it when I say that these are the points, these are the general points in which any interview that you give later will be evaluated. So the second part is how good a code that you write. What is your, code evaluation, right? The third point will be, did you take hints or not? Did you take hints or not, right? See guys, it is generally advisable that when you get a question, first of all, you should try to do it yourself. Socho. You spend some time, you are not able. Let's say you give up. कि नहीं हो रहा है, नहीं ही समझ में आ रहा है. You know that you are close, but you just need that one little ray of hope so that you can get thinking in that direction. So generally, it is advisable that if you spend a large amount of time and you are not able to come up with a solution, you can always ask the interviewer for a hint. Ki, hey, but obviously you will try to tell your approach. Ki, hey, I am thinking in this direction, but I think there is some logical flaw here. Kuch gadbad ho raha hai. I am not very sure, right? Can you give me a hint on what direction I need to think, or what should I, change in my approach? Can you give me a hint? Obviously, if you take a hint, your point goes down. Okay. But this is another criteria on which we do the evaluation. ठीक है. अब भैया अगर hint लेके question कर दिए, then हो सकता है 1 point कम मिलेगा, but you will get full marks for that question, right? So do you take hints or not? That is the third evaluation criteria. Okay. The fourth criteria is, see, the code that you write, the variable naming that you do in the code, now you should write a very clean code. And this is true for any code that you write in industry as well. So people will be looking at what is the quality of code that you are writing. And when I say quality of code, right, देखो, obviously time complexity, space complexity is something, right? But when I say what is the neat code or what is a clean code, right? So your variable naming, okay, the variables that you need should be proper. You should do some proper variable naming so that when a third person reads your program, he should be able to understand. Now, what do I want when I say this? Let's say I write something like this. Function, ऐसा कुछ बता रहा हूँ, function A, int B. I write something like this. Int C is equal to B plus B. Okay, print C, something like this, whatever I'm doing. Now you try to understand, right? Let's say, you know, you take int n and I want to find the sum of the first n natural numbers, right? And you write the function like this. Func A, int x, int n, first n natural numbers, int p. Okay, for loop lagaya, for p plus equal to I, whatever, and you return p. So you see here, if somebody looks at your code, your variable naming should be good so that the person can understand what are your variables doing. So what will be a good way? I will write a function like this. Func sum of natural numbers. Okay. The naming should be proper. Okay. Int n. Then what I will write? Int sum. Full proper naming, right? Are you getting what I'm trying to say? Your variable naming should be good so that people can understand your code. Arbitrary variable naming kabhi nahi karna. Never do this mistake in an interview. आप जब खुद practice कर रहे हो, you can do it. But in an interview, never. Don't use variables like int A, int AAA, int BBB, int CCC, never. These might make sense to you, but it won't make sense to your interviewer. Always use proper naming conventions for your variables and functions so that any person can understand your code in a good way. So इस पे भी आपका evaluate होगा कि आप code variable naming, function naming, how are you doing it? Okay, this is one another criteria. Then the fourth or the fifth point will be, are you writing modular code? Are you writing modular code? What does this mean? Is the student using functions? कि भैया आपको 100 लाइन का, अगर मान लो if you are writing 50 lines code or let's say 30 line code, right? Just giving you an example. Are you writing the code at one place or do you understand the concept of functions? Can you use functions? Okay. So this point will be, are you using functions or not? If you are using functions, and is your code modular or not? Okay. What do I mean when I say modular? You should have different functions. Let's say I ask you, जैसे मैं तुमको एक example देता हूँ, find the first and the last position of an element in sorted array. That was an assignment question, right? So if you are doing this, somebody can do it inside the main method only. Somebody can make a different function for finding the first position, a different function for finding the last position. So this code is much more modular because you have broken up into smaller chunks which more people can reuse. So definitely this code is better as compared to writing all the code in the main method. So this point will evaluate, are you using functions and are you doing modular code or not? Agar aap functions use kar rahe ho, definitely it's a added advantage. Okay. Then after this, what? Are you using comments? Are you using comments? क्या आप अपने कोड को प्रॉपर्ली कमेंट कर रहे हो? Now what did I tell you? You should write clean code that folks are able to understand. So whenever you write anything, just use comments. कि what is my function doing? Why are you doing what you are doing? Just try to write. कि boss, कभी 2 साल बाद कोई और आदमी तुम्हारा कोड देखे, if somebody looks at your code 2 years down the line, he should be able to understand what is the code doing. Please write proper comments. If you write comments, it automatically shows that yes, you are doing clean coding. Okay. Then, and see guys, one of the most important thing in any interviews is never remain silent. Never ever remain silent. Interviewer has given you a question, you will be thinking about it. Always think aloud. Always think aloud so that the interviewer is also aware what is the approach that you are taking or in what direction are you thinking. ऐसा मत करना कि तुमको question मिला, for 20 minutes you stay quiet, just keep on thinking in your mind and then you say I don't know. Even if you are taking 20 minutes, now think aloud. कि hey sir, you know what I'm trying to think. मैं ऐसा सोच रहा हूँ कि I will take an array and let us run a loop and I can do something like this, something like. Basically think aloud whatever you are thinking. You may be right, you may be wrong, no need to worry. But think aloud so that your interviewer understands what is your thought process. And if you are going in the wrong direction, the interviewer will sometimes even correct you. Hey, others try to think in this direction. Okay. So always think aloud and make sure that you are conveying your thoughts properly to the interviewer. Properly. This will also a very, very important parameter on many interviews are evaluated. Okay. And So basically you have to think aloud, and when you write your code now, whenever you are writing code, always explain your code while you are writing. Okay, so when you are coding now, always keep on explaining the interviewer ki, hey, I am writing this loop. You know what this loop will be doing? This iterates over the array and does things. So whenever you write your code, assume that the interviewer is dumb. ऐसा समझो उसको कुछ नहीं आता है. You have to explain your code whenever you write. And it's always advisable to keep on explaining as you write. Because एक बार में you write 50 lines and then explain, it becomes very difficult. So keep on explaining code while you keep on explaining while you write your code. ठीक है? अच्छा. So think aloud and you explain the code when you are writing. And the last point for your evaluation will be, are you giving a pseudo code? Are you giving a pseudo code? Okay. So you should first of all write a small pseudo code before even you do proper coding. So first you come up with the approach, you think aloud, and then you provide a pseudo code. Kaisa likh do ki, hey, I am thinking of doing the lift, there will be a for loop, it iterates, whatever. A very simple pseudo code like I give you guys in the PPT. First give a pseudo code to the interviewer and then only go to the final coding. This is also a very important aspect, right? So these are some of the aspects on which your interview will be evaluated. Okay, a combination of all these things. Okay, and to pass the mock interview, you have to score at least 6 on 10. Okay, so at least 60% is required. Okay, so after your mock interview is done, after some time, the interviewer will give you your marks out of 10. And on what conditions he will evaluate you? On all these parameters that I have told you. Okay, so if you get a marks greater than equal to 6, you are good enough to stay in the module and you will continue with module 2. हम लोग को समझ में आ जाएगा कि yes, you have cleared module 1 test properly and you are aware of the fundamental concepts and logic. So you are good enough to continue with module 2. But in case you fail the mock interview, इससे पता क्या पता चलता है कि boss, you were somehow, let's say, lucky in the test. Okay, but see, because when I take your interview now, I will ask questions so that I can understand your thought process and your way of writing code. Questions tough nahi rahenge, but questions will be, when face-to-face interview hota hai, it gives you a clearer picture of what you have understood, right? So questions won't be difficult, but it will evaluate how much you have understood. Basic. मैं समझ सकता हूँ ना कि boss, what is the space complexity of bubble sort? Okay, if my swap operation is costly, which sort will you tell me and why? तो ये सब चीज तुम explain कर सकते हो and I get a better understanding. I give you a question, I listen to your logic, I see your way of coding, right? Simple ही questions रहेंगे, but I will see it. Okay. Now, if you get a mock score of less than 6, that means something is wrong with the fundamental concepts. And even if you have cleared your module 1 test and come here, you will be sent back. Okay. So if you fail the mock interview, again, you will go back to module 1. The boss, still something is missing with your concepts, right? So you go back, again, practice more questions, again, do some problem solving, again, attend module 1, and then you will again have to repeat the process. And again, a very, very important thing, right? Again, a very, very important thing. Whenever you write any question, okay, this might not be very applicable to our case at this point of time, but in any general interview, first of all, we always start with the brute force solution. And what is the brute force solution? The very basic way that you can think, right? This might take more time. Okay? So सबसे पहला चीज दिमाग में आता है ना, that is the brute force. What is the crudest way of solving this problem? First of all, we tell the brute force to the interviewer. And then the interviewer will tell you, hey, Adarsh, the logic that you have used is a brute force. Can you optimize better? Can you write code in a more efficient way? Let's say you make a brute force in big O of n square. Okay, you write a code that run in big O of n square. And there is a better way that can run it in big O of n. So first of all, always give the brute force approach. And then if you are able to reach the optimal approach, then provide the optimal approach, right? And always try. Whenever you are writing code, at the end of the day after writing code, you should tell time and space complexity to the interviewer. They get impressed, right? Yes, you are understanding what you are writing and what is the implication of the code that you are writing. So first of all, always start with the brute force. Okay, brute force batao interviewer ko. Then the interviewer will ask for the optimized one. Try to optimize your code. See, this might not be this much relevant in this mock interview, but again, this is a very generic thing that you all have to understand throughout your career, right? So always start with the brute force. See, even if you know the best answer now, मान लो मेरे को पता है the most optimal way, never jump at it. at the first place, because then it will give the impression कि तुमको question पहले से आता था. Always make the interviewer show that you are thinking from scratch. I have seen the question for the first time. Even if you know the answer, take some time. First come up with the brute force, then go to the optimal. Cast a good impression that you are able to think, right? And then, yes, I think that is almost everything, right? I have covered almost all the things. This is how you should give a general interview, and these are the parameters on which any general interview is evaluated, and same will be done for the mock interviews. Okay, so these are the 2 steps. So even if you somehow, cheat and, proctor ko ullu bana diye, you clear the module 1 test, you still have to face an in-person interview over here. So if you fail here, you go back. So what is a way for you to be in module 2? You have to clear the test in proctor greater than 60%. You come here, you face an interviewer, you get a mock score greater than equal to 6, and then you are good to go for module 2. If any of these steps you fail, you come back to module 1. Okay, and again you will be with me for another 1 month. Okay, so I hope this is making sense. I think I have tried to cover almost everything. Is this making sense, guys? The process that I have told. My last question is, if any student is already repeating module 1, good question. Good question. Okay. That's a good question. I think we'll get to you guys, right? So the people who are already repeating module 1 and they fail again, then what do we do? I think I'll have to get back on this one. I am not sure. Okay. Will we be able to choose the date of the interview? See, everything. See, it will be flexible, right? But there will be some slot, right? Ki boss, 2 से 4 में आपका interviews होना है. And let's say if you are not available on 2 at a specific time, you can reschedule it to 3. That much flexibility will be there. Okay. Time limit for each question. Generally, it's seen that, if I am the interviewer and I give you an easy question, I will expect that you give me the answer in 15 minutes around, right? If I give you a difficult question, maybe I can take you, give you some 30 minutes of time. It depends from interviewer to interviewer. Okay. Time duration, 1 hour kinds of thing, I would say. 1 hour. Okay. Yeah, there is only one chance. Everything has one chance, right? Okay. We are trying to make it as much, similar to the real life, interviews that you will be going to get. Okay. Pseudo code कैसे लिखे? कुछ नहीं. Pseudo code ऐसे ही होता है for I equal to 0. मतलब कुछ भी लिख दो यार, बस पता होना चाहिए कि क्या हो रहा है. Okay. What after failing more than 2 times? Good question. I think I'll get back to these questions a little bit later. Even I am not sure about this. So, any HR questions? No HR questions. नहीं, see, I will again tell you guys. लगा होगा कि ऐसा मैंने बहुत कुछ भयानक बोला है, but again I will tell you, if you are clear with the fundamental concepts of module 1, if you know the basics of everything, I don't think you will get a problem in any of these processes. That is for sure. But when I say clear, you need to be clear and not ऐसा कि हाँ भाई थोड़ा बहुत आता है नहीं आता है वैसा नहीं. Okay? Yeah, you can use pen and paper for interview for sure. है ना? Where to write pseudo code? Okay, so in pseudo code, I think you can share your screen and either you can write it on a document, Google Doc, या ऐसा कुछ भी कहीं पे भी कर सकते हो. Okay. Yes. So the next action item on my side will be to get an assignment uploaded for you all so that you can practice. Okay. And I will also share some list of questions with you all so that you can practice. Okay. So I will try to share approximately 10 questions with you all. I think that should be sufficient. 10 questions बहुत है, उतना भी कर लो तो काफी है. And then yes, platform of mock interview, I don't know. If someone fails in the module, then the same instructor. No, I'll only be the instructor, right? So you will repeat with me. You will again have to tolerate me for the next 20-30 days, whatever. Okay. Chalo guys, cool hai? So any other questions you can ping either Lakshay or me, right? Preferably if you can reach to Lakshay regarding administrative things, that will be better. Okay. ठीक है. तो बस I will share some questions with you all. 5 से 10 question बना के भेजता हूँ तुम लोग को. And we will also upload it on the portal so that you can solve it. And then, okay. ठीक है. चलो guys, cool. चलो, okay. Good night. Any other things you can, okay. And yeah, I'll share some questions with you all for sure. And an assignment will also get uploaded on the portal via a mock test करके, तो उसको भी कर सकते हो. Can I speak in Hindi? No, speak in English. Try broken ही बोलो. but make sure that your thoughts are being conveyed properly. ठीक है, अभी अगर बहुत प्रेशर पड़ रहा है थोड़ा यूज कर लेना, but try to speak it in English, right? Because in official interviews you will be expected to use English a little bit. Yeah. Okay, cool guys, bye bye, let's meet tomorrow then. Chalo. Okay, I hope most of the things must have been cleared regarding